नमस्कार। आज हम सेट्स को पढ़ेंगे। कुछ स्लाइड्स में सेट्स को डिस्कस करेंगे, कुछ प्रॉपर्टीज को। फर्स्ट हिस्ट्री ऑफ सेट्स है। हिस्ट्री ऑफ सेट्स जो है वो डेवलप्ड बाय जर्मन मैथमेटिशियन जॉर्ज कैंटर। इन दिस टाइम he was first encountered sets while working on problems on trigonometric series. Sets are being used in mathematics problems since they were discovered. Now we will discuss definition of set. In last video we have already discussed the definition, but today we will again discuss. Set is a well-defined collection of elements or object. It is well-defined collection of object, not a collection of well-defined object. Well-defined means whether an element belongs to that group or not. Example, collection of all states in India. And the second one is collection of good cricket players in the world. Here first one is well-defined collection, but second is not well-defined. So we cannot say second is a set, first is a set. If an element is in some set, then we can use the symbol A belongs to that set, or if A is in some set, then A belongs to A. If not, then A not belongs to A. Now we will take some example on next slide. In this slide, we have some example or question that we have to check. First one is a collection of all natural number less than 50. 50 से लेस जितने भी नंबर होंगे नेचुरल नंबर, वो क्या होगा? कलेक्शन होगा किसका? ये नंबर होंगे उसमें सारे के सारे, एंड दिस इज well defined. This set is well defined. Next one, collection of good hockey players in India. This is collection of good hockey players. That is not well defined. This is not well defined. So this is not a set. Collection of difficult topics in mathematics. This is also not a set because we cannot define difficult topics. The collection of all months of a year beginning with letter J. This is well defined because we have months January, June and July. This is well defined. A collection of novels written by Munshi Premchand. This is also well defined. A collection of most dangerous animals of the world. This is not well defined because some elements are dangerous for some people and some are dangerous for another. The collection of all prime integers. This is well defined. Prime integers are 2, 3, 5. So this is well defined. So these are some examples. If we have a set A, then insert the appropriate symbol or in each of the following blank space. So we have to use symbol belongs to or not belongs to. 4 is in the group, belongs to. 9 belongs to, -4 not belongs to, -2 not belongs to, 12 not belongs to, and 0 belongs to. So these are the some examples. Now we will take next slide. In next slide we will discuss description of a set. We can represent set in two ways. First one is roster form or tabular form. In this method, set is described by listing all the elements separated by comma. In this, we will list all elements separated by comma within the curly bracket. And in next, set builder form. Set builder form. Second name is property form. In this form, a set is described by a property Px of its elements x such that Px holds for x. This symbol stands for such that, which is read as set of all x such that Px holds. This symbol is read as such that. These are two methods from which we can represent the set. Now we have some examples based on There are some practice questions. In this, first describe the following sets in roster form. So we have to list all the elements. X is a letter before F in the English alphabet. So A, B, C, D, and E. These are the elements belong to set. X is a prime number which is a divisor of 60. So we have to find all divisors of 60. 1, 2, 3, 4, 5, then 6, then 10, then 12, then 15, then 30, then 60. So we can find from these divisors only prime number. Prime number is 2, 3, 5. These are the prime numbers. So this is, next is x square is less than 10, less than equal to 10. So we can take value 0, plus minus 1, plus minus 2, and plus minus 3. This symbol is less than or equal to. So if we have a case 5 less than equal to 5, then it is true, because either 5 equal to 5 or 5 less than 5. So if one is true, then complete is true. Next is the set of 4 letters of the word better. So we will take one letter one time. B, B, E, R, and T. Next, describe the following set in set to form. So it is 10, 11, 12, 13, 14, 15. So we can write down this set as X such that we have to write down the property. So we can write down it as n plus 1, and value of n is starting from 9 to 14, and n is an natural number. B equal to 0, then this set is 0, x such that x equal to 0. Third, multiple of 3, so we can write down it as x such that x is equal to 3n, where n is integer and n is positive, non-negative integer, so we can write down it as whole number. And last one is 1 by 2, 2 by 5, 3 by 10, 4 by 17. So in denominator we can see that square plus 1 is there. Square plus 1 is there, so we can write it as x such that x is equal to n upon n square plus 1. And we can put value 1, 2, 3, 4, 5, 6, 7. And we can write down also as n is from 1 to 7 and n is natural number. So these are some practice questions based on set builder form and roster form. Now next one, next slide. Next slide is types of set. In this we will discuss types of set. First one is empty set, void set, null set. A set if it has no element and it is denoted by phi. This is the letter phi. In roster method, phi is denoted by this. A set consisting of at least one element is non-empty set. Which set is non-empty? Having at least one element. Singleton set, a set having only a single element is singleton set. Finite set, a set is finite if it is void. Empty set is also finite because number of elements in that empty set is 0. Infinite set having infinite element that cannot be counted. Important is cardinal number. Number of all elements in a set is cardinal number and denoted by number of element in A. Next one, multiplicity of an element in a set is means if an element is written more than one time in a set, it is counted as one element. Example, we have this Now you can say number of elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. No, number of elements are not 9, number of elements are 5 because 1, 2, 3, 4 and 5. 3 is 3 times and 5 is 2 times. So this is types of set. Now next slide, important one, equal and equivalent set. So definition of equivalent set, two finite set. Two finite sets A and B are equivalent if their kernel number is same. Two finite sets. Equivalent sets are two sets if they are finite. Equal sets, two sets A and B are said to be equal if every element of A is a member of B and every element of B is a member of A. It means set A and B are equal. Example 1357. Here 1357 both have same cardinal number and same element, so these two sets are equal sets. Here every element of A वो same ही बात लिखी है. A is member of B and B is member of A, so A equal to B. So from definition it is clear that equal set is equivalent, but equivalent set need not be equal. All equal sets are equivalent, but all equivalent set need not to be equal. And if we have to show two sets equal, then we will use A is subset of B or B is subset of A. Both property we will show A is subset of B and B is subset of A. Next slide. Now some practice questions are there. Which of the following sets are equal sets? So we will find A and B are equal set. C, we will check. D, we have this quadratic, and if we will factorize this, it is x minus 1 square, and value is, we have two value because it is quadratic, so x is 1 and 1, and this is cubic equation. Method to solve cubic equation is hit and trial method. So as you know, x equal to 1 is a factor, so we will divide this polynomial by x minus 1. If we divide this polynomial by x minus 1, it is x square, x cube minus x square minus plus cancel 5x square plus 11x, then minus 5x square plus 5x minus plus 6x minus 6, then it is 6. So this is again a quadratic, and this quadratic we will solve. X square minus 5x plus 6x, factors are x minus 2 and x minus 3. Value of x is 2 and 3. So this cubic equation has solution 1, 2, 3, and this quadratic equation has solution 1 and 1. So which sets are equal? A, B and C are equal. A, B and C are equal set. Now second question from the sets given below, pair the equivalent set. Now equivalent set, finite set having same cardinal number. Number of elements are 3, number of elements are 4, number of elements 4, number of elements 4. So B, C and D, these are equivalent set. Now third one, which of the following sets are empty? Set of all even natural number divisible by 5. Set of all even natural number divisible by 5. 10, 20, 30, 40. So it is not empty. This set is not empty. Set of all even prime is 2. So this set is not empty. Next one, x square minus 2 equal to 0. Then we have x equal to 2. X equal to plus minus root 2, we have two value. but x is a natural number and these two are not natural, so this is empty set. X is a common point to any two parallel line. If we have two parallel lines, first line is this line and this line, then they have no common point, so this set is also empty set. These are some examples based on equal and equivalent set. Now next topic is important topic, subset. What is a subset? Let A and B be any two sets. If every element of A is an element of B, then A is called a subset of B. Where A is subset of B, we can write it as A is a subset of B. Where B is superset of A and A is proper subset of A. If A is subset of B, this is proper subset and this is subset. Now, if A is subset of B and B is subset of A, then set A and B are equal. So, if we have to show two sets equal, then we will show A is subset of B and B is subset of A. And same result is there. Some result on subset. Every set is a subset of itself. First condition. Second is empty set is a subset of itself. Every set, sorry. And total number of subset of a finite set containing n element is 2 to the power n. We will prove this result in the chapter of binomial theorem. Next is universal set. A set contains all sets in a given context. गिवन कॉन्टेक्स्ट में जो सारे सेट को कंटेन करेगा वही क्या होगा, हमारा यूनिवर्सल सेट होगा. ये कुछ डेफिनेशन थी सबसेट्स पे, तो ये हमको ध्यान रखनी है. अब कुछ हम इंटरवल के बारे में पढ़ेंगे नेक्स्ट टॉपिक. बस डेफिनेशन का ध्यान रखना है इसमें हमको. क्लोज इंटरवल है, if a and b are two given real number, if a and b are two given real numbers that a is less than b, then set of all number is closed interval and denoted by point a and b. Here this point is closed point, point a and point b, and these are open point a and b. So this is open interval. Second one is open interval. And in semi-open, semi-closed, semi-open is open from one side and semi-closed is closed from one side and open from another side. And this is important. What is the length of the interval? The difference of final point and initial point is length of the interval, that is b minus a for all intervals. So you have to remind this, that is length of the interval is b minus a. Now next slide. Next one is power set. Let A be a set, then collection of all subsets of A is called power set of A and denoted by P of A. So what is power set? Power set is nothing but the collection of all subsets. If we write all subsets of A, then we have power set of that element. We will write power set as this, S such that S is a subset of A. Power set of A of a given set is always non-empty. So this is important line. Power set of any set cannot be 5. This is always non-empty. Let A be a finite set containing n element and R is from 0 to n, where R is not equal to n. Consider those subset of A that have R elements each, then we know that total number of object n and we have to choose R, then it is NCR and sum of all binomial coefficient is nothing but 2 to the power n. We have some example. A set is 1 and 2, so number of element in the power set are, these are the power set, singleton 1, singleton 2, and this is set A itself, and it is clear that A is a subset of. Now we have some example. Most important question in each of the following, determine whether the statement is true or false. If it is true, then prove it. If it is false, give an example. मैंने कुछ एग्जाम्पल लिए हैं यहाँ, तो उनको हम देखेंगे. फर्स्ट है हमारा x बिलोंग्स टू a एंड x a बिलोंग्स टू b देन x बिलोंग्स टू b, क्या ये ट्रू होगा या नहीं होगा? देन वी विल टेक सम एग्जांपल. x belongs to a, if 1 belongs to a, then a belongs to b, a belongs to b, then x belongs to b, but 1 not belongs to b. This is set, this is set, this is set a, this element belongs to this set, but 1 is not contained in b. 1 is, this is single, this is set, not an element. Here this is an element. So we can take these examples, you can check the examples, and if you have some doubt then you can ask. So this is power set. Now most important, operations on set. This is most important. Operation on set, first is union of two set, as it is clear from its name, union. If we have two sets, then union of sets a and b, all those elements which are either in a or b or in both, and we have the result a union b, all x such that x belongs to a or x belongs to b. Let us suppose set a have three elements and set b have these elements, then a union b is nothing but 1 2 3 4. We will write one element one time. Next one, intersection of two sets. Let a and b be two sets, then intersection of a and b set of all those elements which belong to both a and b, all x such that x belongs to a and x belongs to b. We have same example, set a is 1 2 3, set b is 2 4, then their intersection is nothing but 2. Next, if their intersection will be 5, then these two sets will be disjoint set. डिसजॉइंट की सेकंड जो है वो नाम है म्यूचुअली एक्सक्लूसिव, प्रोबेबिलिटी में पढ़ेंगे इसको. नेक्स्ट वन है डिफरेंस ऑफ टू सेट्स. लेट ए एंड बी टू सेट, देन डिफरेंस ऑफ ए एंड बी इज रिटन एज a minus b, and is set of all those elements which are in first set but not in second set, which are in a but not in b. Same is written as x belongs to a and x is not belongs to b. We can take some example. Set a 1 2 3, set b 2 4. Now a minus b is nothing but all those elements which are not in b, so it is 1 3. Also b minus a is 4. Set of all those elements which are not in here. b minus a is all those elements of b which are not in. नेक्स्ट वन है सिमेट्रिक डिफरेंस. क्या है? a minus b, a delta b is a minus b union b minus a. If we have Venn diagram, this set is a, this set is b, then a minus b is this, b minus a is this. So symmetric difference is a union b minus a intersection b. Same result is there, and we can write down it as x जो है वो a और b के इंटरसेक्शन में यहाँ नहीं होना चाहिए, इसके अलावा दोनों में हो जाएगा. दिस इज a only and this is b only. Complement of a set, let b be a universal set, then this or a dash will be the complement and written as a complement is nothing but universal set minus a. Define a set of all those elements of U which are not in A. This is complement of a set. Now next one, move to next slide. Next slide, there are some laws. First one is idempotent law. If we will take set A and use property operation union, then A union A is A intersection A is A. Commutative law, A union B is B union A and A intersection B is B intersection A. Then associative law, distributive law, A union B intersection C is A union B intersection A union C, and A intersection B union C is A intersection B union B intersection A intersection C. This is associative property, and most important is De Morgan's law. De Morgan's law, A union B complement becomes A complement intersection B complement, and A intersection B complement is equal to A complement union B complement. So we can also prove this result by using Venn diagram. So on last topic, or in 18th slide, I will discuss Venn diagram for three sets. Now next, there are some formula related to set. First one is number of element in A and B is number of element of A plus number of element in B. These results we can prove with the help of Venn diagram. This is symmetric difference and number of element. These two results are important results. Number of elements exactly 2 and number of element in exactly one of the set. And one result is there, one more result is there, that is only A only, B only, C only. So we will prove these results in last slide. And now some question. So we will take so we will use Venn diagram for three sets: set A, set B, and set C. Set A, set B, and set C. So this small space is nothing but A intersection B intersection C. This space is nothing but B intersection C. This complete space is nothing but A intersection C. And this complete space is nothing but A intersection B. These are some intersection point. Now we will have to find only property A only. In property A only, again we will draw A, B, C. So we will find A only. So A only is nothing but this. This is A only. So how we can find A only? We will take all A. Minus में this and plus में this result, because A intersection B intersection C को हमने दो बार सब्ट्रैक्ट किया है. इसमें A intersection B में सब्ट्रैक्ट किया था एक बार इसको, और एक बार इसको A intersection C में सब्ट्रैक्ट किया था, इसलिए हमने क्या कर दिया, इसको प्लस कर दिया. So this is nothing but A only. So through this we can find B only and C only. So if we find B only, then result is this. And if we find C only, then result is this. And if we add all these terms, then we have exactly one result, and that result is here. This result is same. That result is number of element of A plus number of element of B, number of element of C minus में 2 times of their intersection plus में 3 times of their intersection. So this is the formula. So with the help of Venn diagram, we can make formula. As exactly 2, we can also make this formula. So now we will move to our test section, and there are some problem based on sets. First one is, if set A is this, set B is this, then we have to find their intersection. So in intersection we have to take common elements, and in these 1 to 3 we have only one common element, so option B is correct option. Number of all subset of a set with 5 elements. If a set has n element, then its subset are 2 की power n, so it is 2 की power 5 and 32 elements, so option B is correct. A set with no element is called empty set. जिसमें कोई भी एलिमेंट नहीं होगा उसको क्या बोलेंगे, empty set बोलेंगे. Union of any set A with empty set. If we will take union of any set with 5, then we will have that set, because in union element comes from either first set or second set. If we will take intersection, then intersection will be 5, because we will take take elements from both sets which are common to both sets. If A is subset of B, B is subset of C, then what is A is subset of C? This is correct statement. Now next, in this slide, section B, short answer question. Write all subsets of A and this set. Mean to say we have to find its power set. And in power set, first is 5, then we will write singleton 1, singleton 2 and 1, 2. And the second one, x is an integer and x is from this is write A in roster form. So we will write all integers between these, minus 1, 0, 1 and 2. Define power set. What is power set? Power set is nothing but collection of all subsets of a set. If we write all subset of a set, then it becomes power set. So it is example of a power set. This set is set A, then power set is 5, 1, 2 and 1, 2. And the important property about power set is always a non-empty set. If set A is this, set B is this, then find A intersection A union B and A minus B. A union B is all elements from either A or B or both. So we have 1, 2, 3, 4, 5. And difference of two sets is all elements of A which are not in B. So elements are 1 and 2. So next, move to next slide. Now, move to next question. State whether the following pair of sets are equal or not. X is a letter in the word math, or X is a letter in the word then. So both are same. So these two sets are equal sets because they have same element. And then next question, set U is this, set A is this, set B is this. U stand for universal set. Then we have to find complement. So what is the meaning of complement? All elements of universal set except A. So we will not take 2, 4, 6 and 8. So complement of A is 1, 3, 5, 7. 1, 3, 5, 7. Next one, A union B. So union of A and B. A union B is what? 1, 2, 3, 4, 6 and 8. Next one, A intersection B. That is common element from A to B. Common is 2 and 4. This is, we have to prove this property is associative property, distributive property. A intersection B union C is A intersection B union A intersection C, using example of Z. So we will take some example and easily we can prove this. We will take A 1, 2, B 2, 3, C 3, 4. So we will, what we have to find, we will take this element 1, 2, 3, 2, 3, 4, 3, 4, 5. So first we will find B union C. So B union C is 2, 3, 4, 5. And now A intersection B union C. A intersection B union C. Common element from A are 2 and 3. And in next, A intersection B is 2, 3. And A intersection C is A intersection C is 3. And their union is nothing but 2, 3, so both are equal. So with the help of an example, you can prove this. Now next question, set A is this, set B is this, set C is this, verify that. Same problem is there, so we can easily check out this problem. So this is last slide. We will discuss in next video about the properties of set in practical application. So stay tuned for the next video. Thank you. Please share and subscribe my video. Thank you.